Hi Year 9. This is our fourth and final lesson for the topic of numbers of any magnitude. In this lesson we're going to look at scientific notation. So far we've covered significant figures, measurement conversions, and error in measurement. Now scientific notation is a method of writing very large or very small numbers in a concise form. So instead of writing 320 million with all of these zeros, we can write it as 3.2 times 10 to the 8. With small numbers, instead of writing this with all of these zeros, we could write it as 4.5 times 10 to the negative 6. Now on the calculator, we use the times 10 to the power of x button. On older calculators, you might see EXP for this button. So let's have a look at how we use the calculator. Divide 4.2 times 10 to the power of 3 by 1.6 times 10 to the power of 6. Now what you can't do is do it straight out like this. And the reason is order of operations. Multiplication and division are done in order from left to right. And at each stage the calculator is going to calculate the answer. You could do it if you put that last number in brackets. Or you could use your fraction button. But it's much easier just to use the times 10 to the power of x button like this. I'm going to just type in 4.2 times 10 to the power of 3 divided by 1.6 times 10 to the power of 6. And that will do the correct order of operations for you. And we press equals, and our answer is 0.002625. Now what happens when we multiply by a power of 10? Do you remember? We move the decimal point to the right. So for example, if we've got 1.235 and we multiply that by 10, this decimal point is going to shift one position to the right, giving us 12.35. Suppose we multiply by 10 cubed. That's equivalent to moving the decimal point 3 places to the right. Why is that? Because 10 cubed is the same as 10 times 10 times 10. And for each of these 10s, we move the decimal point one position. So if we've got 1.235 times 10 cubed, we're going to move it once, twice, 3 times, which is going to give us 1,235. What happens when we divide by a power of 10? The decimal point moves to the left. Here's an example, 12.35 divided by 10. We're going to pick this decimal point up and shift it one position to the left, and that gives us 1.235. Suppose we want to divide by 10 squared, we're going to move the decimal point 2 positions to the left. Here's our example, 12.35 divided by 10 squared, the decimal point is going to move 2 positions to the left, and we'll end up with 0.1235. Now to write a number in scientific notation, we move the decimal point between the first two non-zero numbers. Now you've heard this before, non-zero numbers, they're significant figures. So suppose we've got 180 million. We want to move our decimal point, which currently sits here, to between the first two non-zero numbers, so in between the 1 and the 8, like this. Next we multiply by 10 for every position that the decimal point has moved. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So we times 10 to the power of 8. We don't need to write all of these zeros now because they're not significant. And so our answer is 1.8 times 10 to the power of 8. It's the same for small numbers. We move the decimal point to sit between the first two non-zero numbers. Then we're going to divide by 10 for every position that the decimal point has moved. So let's count those. This is where it was. 1, 2, 3, 4, 5, 6. So we're going to divide by 10 to the power of 6. Now here's the thing. To keep the notation consistent, we don't really want to write divide, we want to write multiply. So instead of dividing by 10 to the power of 6, we're going to multiply by 10 to the power of negative 6. Now, if you remember your index laws, then you should realize that 10 to the power of negative 6 is the same as 1 over 10 to the power of 6, which of course is the same as 1 divided by 10 to the power of 6. So it is the same. How do we remember? It's really easy. For large numbers, we've got a positive index, And for small numbers, we have got a negative index. Now, scientific notation and significant figures go hand in hand. It's very common to round scientific notation to 1 or 2 significant figures. If it's not stated, then use the same rounding that's in the question. Here's the question we did earlier on the calculator, and we ended up getting this answer, 0.002625. Now, firstly, we're going to turn this into scientific notation. So I'm going to move this decimal point to sit between the 2 and the 6, and it's moved 1, 2, 3 positions. And it's a small number, so it's 2.625 times 10 to the negative 3. Now we're going to round this to 2 significant figures. Look at the next digit. The 2's small, so we can throw it away. So this is approximately equal to 2.6 times 10 to the negative 3. Now, of course, we need to be able to write numbers in scientific notation, but sometimes we have to convert it back to a regular number or undo scientific notation. So if we want to write scientific notation as a regular number, we have to move the decimal point back to where it belonged. So suppose we have this 2.3 times 10 to the power of 5. Start by writing the 2.3. Now we want to move that decimal point 5 positions to the right, like this. We're going to need to put some zeros in underneath there. And you can see how I got rid of that decimal point there. So our final answer here is 230,000. It's the same with small numbers. Again, we're going to write the 2.3. This time I'm recognizing this is a small number, so I'm going to write that 2.3 some ways to the right. And I need to move this decimal point 5 positions to the left. So like this. Again, fill in underneath and make sure you put your decimal point in and a leading 0. And so our answer is 0.000023. Now, another reason to write numbers in scientific notation is it makes it easier to order them. Suppose we've got this question. Put the following in ascending order. Remember, that means smallest to largest. 150 million, 3.2 times 10 to the power of 9, 1.7 times 10 to the power of 8. Now, it's difficult at the moment because they're in different notations. But if we turn this one into scientific notation, we can compare these powers. This is 1.5 times 10 to the power of 8. Now we know that these two are of similar magnitude. This one's the smallest, then this one, and this is the largest. So here's our answer, 150 million, then 1.7 times 10 to the power of 8, and then 3.2 times 10 to the power of 9. Now, so far this lesson has been very theoretical, but scientific notation is used extensively in the sciences. In fact, you've probably come across it before. So here's an exercise for you. Pause the video and go to Google and look up all of these measurements. I want you to write them in scientific notation, correct to 2 significant figures, and I've given you in brackets the unit that I want you to use. Let's finish off with a problem. The speed of light is 3 times 10 to the power of 8 meters per second. If the distance from the Earth to the Sun is 1.5 times 10 to the power of 8 kilometers, how many seconds does it take for light to get from the Sun to the Earth? Now, this is a distance, speed, time problem. So if you want to, you can use the triangle to help you remember the formulas. So D, S, T. And in this case, we want to know what the time is. So time is equal to distance divided by speed. Now, our distance is 1.5 times 10 to the power of 8 kilometers, and our speed is 3 times 10 to the power of 8 meters per second. But we've got a bit of a problem because we've got distance in kilometers and speed is in meters per second. So we need to change this kilometers into meters. So we're going to times by 1,000. Now we're just going to put it in the calculator. Probably we'll use the fraction button, but still can use a scientific notation key. So 1.5 times 10 to the power of 8 times 1,000 divided by 3 times 10 to the power of 8 gives us 500 seconds. Now hopefully you did the exercise from before, and if you did, here are the answers. You might have something slightly different, and that will just be because you went to a different website than me. So pause the video and see whether you were correct. Now that's the end of this topic, numbers of any magnitude. If you're wanting to continue on with the measurement strand, the next topic would be surface area.